Hello and welcome to chapter number 2 of Docker Swarm High Availability Cluster. Here in this video, we are going to discuss about some key concepts related to high availability of Docker Swarm cluster. So let's start. Here we need to understand that whole Docker Swarm cluster is actually working using distributed architecture. Docker Swarm operates using distributed architecture composed of manager nodes and worker nodes. If you look at this picture over here, I have 5 Docker hosts. Now this Docker host can be physical machine or virtual machine, but these 5 Docker hosts actually compose cluster. Now, out of these 5 Docker hosts, each and every Docker host having one specific designation. If you look at this, here I have manager A, B, C. I have 3 manager nodes and 2 worker nodes. Now, let's understand the whole concept step by step. First of all, we call it nodes. Whole Docker, any number of Docker hosts you have, all of them, we call them nodes. So if you look at this picture, we can say that I have 5 nodes inside my Docker cluster. Out of these 5, we have 3 manager nodes. Manager nodes having responsibility to handle orchestration and management of cluster. Whenever you will deploy any service, we are actually deploying this from manager nodes. If you have multiple manager nodes, out of this 3 manager nodes, one will have extra responsibility. We can call them leader node. Leader node is like a team leader. You can have multiple manager nodes, but out of any number of manager nodes, you have one leader node. So, leader. One manager node is chosen as a leader and coordinates all decision. So, leader node is actually main node over here out of all the manager nodes who is actually executing the task. Of course, when we are actually executing any task, it will concern with other manager nodes as well. But the main task will be executed from leader node. And finally, we have worker node, execute the task assigned to them. So leader node will assign them task and worker node will execute this task. Now, how this distributed architecture is actually working, how you can choose leader node among multiple manager nodes. We need to understand this algorithm as well. And we call this algorithm Raft consensus algorithm. Now, we are going to understand the whole Raft algorithm. Raft algorithm is kind of distributed algorithm. Now, let's start. The Raft consensus algorithm is a method used by distributed systems like Docker Swarm to ensure that they can agree on decision even if some parts of the system fails. This is what the main fundamental of high availability. How manager nodes going to communicate with each other, how they are going to choose leader node, what happens if anything like failure occur over there, and how Raft is actually going to provide high availability. Docker Swarm uses the Raft algorithm to maintain high availability and ensure the system runs smoothly even if some manager node fails. Now, if I will give you example, then you will get better understanding. So what we are doing, I am going to provide you step-by-step process explanation. Now, first of all, I just want to tell you that here, actually, everything is happening between manager nodes. Leader nodes don't have any responsibility over here. Okay. So right now what I'm doing, I'm just going to delete leader nodes because we just want to concentrate on multiple manager node. Now the first thing first is, if I have 3 manager nodes, how we can choose leader node. And this whole process is actually starting by selecting the leader node. So let's understand. The first process we have is leader election. Let me close all this so you will get clear pictures. See, suppose if we have node A, B and C, start Docker Swarm. Node A, B and C initialize the Docker Swarm cluster and become potential leader candidates. As election is held and node A is elected as a leader, a majority quorum of nodes is required to agree on the new leader. Node B and C vote for A, forming the quorum of 2 out of 3 nodes. Node A is elected as a leader because it receives votes from quorum of nodes, ensuring the election is valid and consistent. Now, you may have this question that why A, why not B, or why not C, right? Let me explain you the whole process and you will get better understanding. First of all, suppose if you are building up a Docker cluster with 3 manager nodes, you will set up this host step by step, right? Whenever you will set up first host, let's say that I'm going to set up manager node host manager A first. When it will start, it will find out that where is my leader node. Now we don't have leader because this is our first host. There is a timeout period. Let's say that this will wait for 30 seconds. If within 30 seconds, manager A nodes get able to contact leader node, then it is okay. It will accept this particular host as a leader, but if it is not going to get any detail from leader node, then after 30 seconds, manager A will say that, okay, we don't have leader, so I am going to election and I am considering myself as a leader node. Same thing will happen with the manager B, but manager B is like we are starting manager B after manager A, right? So when manager B will start, it will find out that we have manager A who is actually participating in leader election and they are already declaring itself as a leader. So what we can do, we will help them and we will vote in favor of A. Same thing will applicable for the manager B, C as well, and they know that now this particular manager A is participating as a candidate of leader, we will support them. Now, this manager A will be leader node if multiple Docker hosts giving majority of Docker hosts giving them vote. I will definitely tell you that how they are going to find out the majority. Let me explain you this as well. This is a quorum number and this is a voting requirement and we have to use this equation. So right now, suppose if I'm talking about N means number of Docker hosts we have in our cluster. So if you look at this, here we have 3. So we can say that 3 divided by 2 plus 1. Because I have 3 Docker hosts, I can say that 3 divided by 2 plus 1. Now here, if I'm going to use 3 divided by 2, it would be 1.5. But we have to go with the round numbers. So I am going to type 1. Not 1.5, 1 plus 1 equals to 2. So, right now, manager A can be leader if manager A will get 2 votes. Now, if you are in the election, you can consider your own vote, and if manager A will get any vote from manager B or C, it will become leader node. Okay? Definitely, if everything is going smoothly, then no need to worry. It will get vote from both B and C, and finally, manager A will become leader. We can say that right now, manager A is becoming leader. The only thing is we started manager A first, then we have started manager B and C. That's the only reason, because timeout period and all this happened with manager A early, then B and C. So, this is how we are choosing a leader. Now,
Sorry guys, sorry to disturb you. I know you all are enjoying the session and suddenly it stopped. But if you want full video or if you want full Docker course having 130 plus videos including projects, you can become our community member. Enrollment link is in description. Moreover, we also provide 24/7 support, weekly lifetime live session with Bhavesh Atara, updates and completion certification as well. Still you have any queries regarding it, you can contact me on my personal number. Thank you.